Hey guys, Brad here. Had quite a bit of time off over the Christmas break. Had a lot of requests over the past few years to, make videos on doing the actual repairs, changing components, that sort of thing. Most of my videos are after I've already done a repair, kind of showing what I did, and mostly for the customers can see that their boards are working before I return them. But again, a lot of requests coming in to show me doing the actual work and kind of going over what I'm using and techniques and that sort of thing. So I ended up setting up my bench with a camera, and I've got put a monitor over here and a few other things where I can switch scenes. Typically, I don't like to edit. If you look at my other videos, I have the ability to switch cameras and stuff with one of these little um, uh, Stream Deck units that ties in with a little video tool, OBS, that I use, and I can just switch between the different cameras and basically do it all in one shot. I don't really want to spend a lot of time editing videos and all that. So I'm trying to do the same thing here. So I have a webcam that you see here. I have a bench cam. At some point, I might have one over my shoulder that comes in to get a different perspective. And then I have a roaming camera kind of on my phone that I use. Behind me is my that's my test bench, I call it primarily. So there's like an 8 foot section there where you see the board and the meters and the scopes and all that. That's typically where I'm troubleshooting boards and testing them, and they'll run overnight. I've got a couple spots over there. And then this section of the bench, it's kind of an L. You can see a drill press, a vise, and I've got some other things there where I do the ribbon cable builds and all that sort of thing. And again, I do have a computer and a monitor up over on that bench where I can open schematics and use some of the tools that I have that are, computer-based, FPGA cat box and slice tool, and there's some logic analyzers and things like that that come in via USB that I use. But here on the bench, I've made a couple changes here recently. Let me switch over to that camera. So here is the bench. So what you see here is just the stool I set in, the lab stool with the arms where I like to position it. The actual bench, the surface here, the flat surface is kind of low, so I've always used a box. It's like a cardboard box, and I put some of this black high-speed tape on it. Well, the box kind of gets a divot in it, so about a few weeks ago, I was on Etsy for getting some Christmas gifts, and I did a search for a wooden box with the same dimensions, roughly 13 by 9 by 6 high, and found a place, $50, free shipping, and they did laser engraving or etching on the wood as well. So I opted to get this. So this is just a cardboard cover. I have to protect it, but I'll take that off. So you can see, da, 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 da. So it's a bamboo box. I had them do the Williams logo, which I have a vector file of that, and then my name down here. Actually, I can switch over where we've got me down there in the bottom right. So um, anyway, so this is just a box. It does open up. It's got some nice hinges on it here and little magnetic closure. And then right now in here, I just have some stuff for PCB solder massa green, and these are UV lights and things I use to cure it. Sometimes the stuff gets a little stinky, so I figured I'll just put it in the box and know where it's at and keep it from smelling. So just again, I just made a little cardboard with some tape on it. It just fits right over the top. So that's kind of the working surface. And as this thing gets mucked up with flux and alcohol and goop, I can either just put another coat of tape over this or just replace it with new. So this video, what I plan on doing is kind of going over a friend of mine, Mitch, who lives locally. I've done some work for him. He's got an arcade opened up. I've been out there. He's given me some boards, some excess boards. He's cleaned out a storage unit, and really good guy. In any case, he's got a Defender set. I reworked and had it up and running for a while, and it went out, and got the boards back from him, checked it out, and it turned out the one of the EPROMs had failed on it, which happens. And so I put a new EPROM, tested it, ran it on the bench for like 36 hours, took it back out to him, put it in the game, and within 5 minutes after getting it, back up and running, the thing went out again. And checked the voltage on the power supply, which had recently been replaced, and he changed some connectors too. So again, it might have been cranked up because it had some connection issues, but the voltage was pretty much 6 volts on the thing. So there's some EPROMs that really don't like it. So I took the ROM board back, figured out what there was a bad EPROM, got that replaced. And I said, with all the boards and stuff he's done for me, I said, I'll give you a full restored board set for that Defender. So if in the future, if something goes down on it, you can just swap out, either the whole set or just one board at a time, the ROM or whatever it may be. So I've got the ROM board done, and I'm getting ready to do the I/O board, and I figured that would be a good um, lead in here. So here's a Defender ROM board. This is the later series ROM board. I do have an early one here. I guess I can kind of go over the um, the differences on them. So here's an early one. Here's a later one. Again, they bolt in the same location, but the earlier one here literally just takes the inputs, come in. I can kind of explain how these things work. So out on your control panel, whether your leaf switches or your joysticks or whatever they are, typically what they're doing is just making a switch closure between ground and these input pins. And these are normally pulled high. There's a 4.7K network resistor over here. One pin, you see that big thick trace is at plus 5 volts. And it comes out of all of these legs independently as a pull-up resistor to through 4.7K to plus 5. And then you've got a resistor and a capacitor for each input as well. And those are basically to filter out spikes and things like that. In the kind of slang term is called a snubber circuit. And it works quite well for AC noise or surges or spikes or something like that. A lot of times they use them in inductive stuff. And again, Williams is really good at inductive devices from the pinball world with all of their solenoids and things like that. So they've got really good handling of stuff coming in from the outside world. So they're essentially computers, what the game boards are. So they come in through these input pins, they go through this number circuit, and then they feed into uh, three of these 4049s. These ICs are inverting buffers. They basically isolate the PIA from the outside world, and as well as invert whatever. If the input is plus, the output is ground, and if the output is ground, the input is plus or high in this case. So they're basically the same IC as a 7404. I don't really know why they went with the 4000 series on these. Maybe because um, they were more abundant at the time. And again, these inputs is not real critical, and the PIA is pretty tolerant to these. And these 4000 series were, they support the CMOS as well as bipolar, uh, like the 7400 series stuff. So anyway, so these PIAs on these early boards, they used two banks of 8 here. So you had 16 inputs. And then there's also a couple input lines for the chip select and that come in through the ribbon cable from the MPU that also use two of the gates on this early board. And the well, it could be on the later board as well. So the later board, they added these 257s here because the problem was you could only get 16 inputs here, and there's 20 pins. Two are dedicated for ground, so that leaves you 18. And then they use two keys here. And I'll show you later on the later boards where they wanted more inputs what they did. So they put these 257s, which basically have an A and a B for inputs and then one common output. So it switches between each one. So they're only using one bank on the PIA. So 0 through 7. And they can switch back and forth. So you get 16 inputs there. And that worked great for Defender because it was limited on inputs. But when they went to some of the other games, they said, we'd like to really use all these pins. And so then if we look at a board that was used on, the first one was Stargate, and then Joust and Robotron, and Bubbles, Splat use this board. There's none of the pins are cut. So you have two grounds, and again, then there's 18 inputs, and they're all active. And they all go through these 4049 buffers, and then through the 257s here. And they ended up needing those two inverters still, so they added a 7404 on the board to take the two for the chip select coming in here. And then there's a filter cap for the power. And again, the power comes in through the ribbon cable as well, and ground, where most of the other boards have a separate power connector. This board draws very little current, so they just take it all through the ribbon cable. You've got a little electrolytic filter cap for that 5 volts here. And then the one we're going to be working on is actually here. And then there's also a two jumpers on the Defender board. So one of them basically tells the game if it's a cocktail or not. So that means if you choose a two-player game, if this pin is pulled to ground, which is the jumper in place, then it knows it's an upright game, and when you player two, the screen will say in the same orientation. But if that pin on the PIA is pulled to 5 volts, which is that resistor there is a 4.7K, if you cut the ground resistor out, then the 4.7 will pull it high, and it tells the game that, hey, this is a cocktail, and when players two turns, it knows to flip the screen for player two because the people are sitting on opposite ends. And this other jumper that they used on here was basically to enable these 257s to flip between the A and B or not. And again, they got rid of that later. They just always flip it. It's more coding. If you're only using, 8 or less inputs, then you really don't need that whole switching capability that it gives you more inputs. And again, the PIA is a peripheral interface adapter, and it was basically, most of the microcontrollers at the time were limited to their address space of, 16 bits and then 8 bits on the data lines. So you were pretty limited there. So by adding PIAs and such, you could really increase your I/O count and communicate with more stuff out there in the world. Um, the physical I/O peripheral world. So that's the term peripheral interface adapter is the PIA. So those are most of the, kind of describes the components on here. I do have a ability to zoom I added to this. So if I hit this little button here, I can get a little closer and we can take a look at the board here. The one thing I wanted to note on this board here, if you look right here, trying to get that centered here, there is a capacitor here. These are called these are glass passivated capacitors. These are non-polarized ceramic capacitors essentially, and they're used for decoupling on most of these ones that you see at the top of the chips. So basically what they're doing is they're like a little buffer. They can store a little electricity. So as these chips are outputting and driving other chips, they need current to feed them. And if you don't have these decoupling capacitors, as they draw current, you can create pulsing induction and noise, electrical noise for other ICs on the board, and can cause problems. So you put these decoupling capacitors as close as you can to the power of each IC. And so this one has one over here. There's one here for this one, and then this one has his here. This one has one here. You've got this one here, and then the PIA that's broken is here. And then also on these ribbon cables, this is a 20-pin ribbon cable here. These are what they call IDC, insulation displacement connection. That's how these things are connected. They have basically a V, and then the wire, when you press that ribbon cable in, it comes in, and the little V is sharp kind of on the edge, and it'll cut through the insulation. It'll displace it. And then the metal contacts will make contact with the center conductor, and it's just a friction fit, force fit, and over time through vibration, heat, cold, expansion, contraction, and oxidation, these things give out pretty much. So if any board that comes in to me, I replace the ribbon cable. I make them myself. I use original 3M parts that I bought. I have a real nice 3M press and special guillotine cutters to get really square 90-degree cuts. So for me, it's not worth the trouble, even if they look nice. It's just not worth it. So most people, when you buy these, different arcade shop, they come with this end here that's soldered in, and all 20 of those pins are within close proximity. A lot of them, the traces are on the top side, so there's really not much bonding here. So it's real easy to lift a pad and cause a problem. So, my take on these boards is let's preserve them, but do as least amount of harm as possible. So if you can get away without having to desolder all of these and then resolder a new one in, that's my preference. So usually the failure on these is the cable. So if you're able to, there's different manufacturers they use on these. I think I have another one here. This one here is a CW brand. So they use a different connection here, but they all come apart, and I can show you on this one here. Let me get rid of this guy. So we'll pry this guy up here, and then on this other side, usually what I do is I'll get in here with an X-Acto between, let's see here, in the seam here, and I'll get the knife in and just get a little pry, and then that's usually enough. I've got like a little pry tool here, a little snap-on pry tool, and I'll get that tip in here, and then I'll go to the other side and just kind of walk it up. So once I get that off, and you can see the back side of it here, it's got little slots where all those little holes in there. That's where the little V's that cut into the wires are. And I can, am I zoomed in here? No, yeah, I was. So you can see what they look like there. So what I do is I take this and pull the ribbon cable out of them gently without, try to pull them in the same axis that they go in. This will give you a better view of them. So there's the old ribbon cable. You can see where those little V's have pierced through and captured each wire. Served many a year there since 1980, 81, whatever. And here they are. You can see them there a little better maybe. And then I have the capper here. So what I do is I make up the ribbon cable with the just like this. Let me pan back out here. So this is how I make the ribbon cable up. That looks like this. And I do have the other ends. And if these are broken or failed, or if I'll inspect these. If there's corrosion, then they get replaced. But if everything looks good, and I don't need to, um, I don't have to. So I have the ability to put a new ribbon in here, and then using my 3M ribbon cable press, I can get in here and press this back down and force the ribbon through the IDC, the insulation displacement connection portion here. So that's done, and then usually what I'll do is also on my bench, I probably should go over what I use on the bench here, but I've got a little alcohol pump unit here that I can just pump, get some alcohol up, and then I take old t-shirts. I always wear a t-shirt, and I cut them into little, I don't know, maybe 2-inch squares. I'll sit for an hour, and make enough of these for a year probably. And then I just do that, get them wet with alcohol, and then I wipe down, get the dust off. Some of the boards, if they're really dusty or really bad and grimy, um, I take the labels off, and once I strip all the components I'm changing, I'll put them in the laundry tub with Simple Green and they'll soak, and then I'll scrub them and rinse them, and then I rinse them with I have an RO system in my house, so I use which is reverse osmosis, and by running reverse osmosis your water through that, it through an RO filter, it takes all of the minerals out, any conductive minerals we call it. So if you just use tap water, a lot of times there's calcium, magnesium, things like that in the water, and when you rinse the board with water, and then I put mine in the oven at 170 degrees, but even if you just let them air dry or have a fan on them or whatever your method is, um, as the water, the H2O leaves, the conductive minerals, calcium, magnesium, whatever, stay behind, and they like to, get between the terminals and things like that. Especially, these dips probably aren't much of a risk, but on some other stuff that have, closer than zero point 0.1 spacing on some surface mount components and things like that, you can run into issues, especially if you have hard water. When they say hard water, they mean the calcium, magnesium, not so much iron. And um, so this one though, I cleaned up, got the edges all clean with the little alcohol here, and I actually mix this up myself. So what I use, I know a lot of people use the IPA, the isopropanol, high 99%. I'm not a big fan of it. I've been using this for years, and I mix my own in this container. Let me see if I can reach up here and show you what I use. So 90% denatured alcohol, and it's pure stuff. It's a real good solvent. And then I mix that, which is hard to find now. They've changed the name of it. But then about 10% of, oh, that's the same thing. I've got extra cans here. Here we go. They now call it painter's solvent, but it's naphtha is what I'm interested in. So about 10% naphtha and 90% of denatured alcohol, and you buy this stuff at Home Depot, Lowe's, whatever your hardware store is, and it works great for cleaning flux and cleaning the boards up, and it's probably cheaper than IPA. So um, that's what I use. So on this board here, I guess let me power up my soldering iron and my desoldering station here. I guess we can go through and do some of this now. So for that busted capacitor that I showed you there, I do have exact replacements. I have saved searches, and I've found some of these. That's a point, .01 microfarad capacitor. So here's a brand new one, and I know what the lead spacing is on those. So I have a little container here. You know, these are all kinds of little gadgets. Some of these I designed and 3D printed myself for different spacing on different capacitors. This is for the soundboard, so this is the main cap. So this gives me the exact lead spacing for those. And this is the one I use a lot here, just standard, you know, spacers. So I know on the spacing on these is a 5. So let me zoom in a little bit here. So there's 5 right there. And what I do is I put that right in the center. I can shift it left and right with my thumb, eyeball it, and then just, whoops, then just fold the leads down, and then make sure they're perpendicular with each other. Because sometimes you'll get them and they'll be offset, right? So you can just tweak them a little bit if needed and get them so they're straight. So that one's ready to go. And then the electrolytic on here will change out. And what I do with these, this is a pro tip. I'll probably show this in more videos in the future, but nothing drives me crazier than when people take, you know, through-hole components and they just bend the leads over. You know, they put them through and bend them and then solder them. And then when you go to desolder them, they're all folded left to right. So on capacitors, you know, radio-leaded electrolytics like this, and this is a Nichicon 50 volt, 150 microfarad, 35 volt Nichicon. I buy these brand new from Mouser. But what you do, here's the tip. You take these legs and you bend this one in about 45 degrees and you bend that one in about 45 degrees. Now keep in mind the longer one is always the plus, so we know that. So here's the cap sitting like this. They're crisscross applesauce, right? So let me switch my camera back out. So then what I do is I'll get my solder and I just flow some fresh solder into, let me get that where you can see it. So here's that capacitor. And then I'll go through all of these. We're going to change the Molex 10-pin headers as well. 2 of them, so there's 20 pins. I normally have a little activated charcoal um, exhaust fan here, you know, for the fumes here. But I've been doing this for 40 years without it most of the time, and I think for a couple of videos I can do without it. The solder I'm using here is, you know, Kester um, Rosin Core 44. This is typically 60-40. Sometimes I use a 37, which is eclectic, they call it, which basically means it goes from a liquid to a solid in a very short transition point. It doesn't go to that kind of gel phase. Not that that really bothers me. And then here's the capacitor. I'll just hit that too. So now we've got, you know, fresh solder on the capacitor, on that busted decoupling capacitor, ceramic one, and then I've kind of reflowed in. What that does is you're kind of, by mixing the solder on the outside of the lead, you end up with an oxide layer that forms it. The melting point is actually different than what it was when it was originally flowed because it oxidizes. And then by putting the new solder with some flux in, the solder will wick down inside and will desolder much easier. So might be noisy. I don't know how my sound canceling will do. But I've got a Hacko 470B. It's a bench. Let me zoom down here. So this is it's an 802 handle, but it's been upgraded. I forgot the model, but the heater and stuff is from a newer gun. And so in here, you can remove this. And I make a lot of my own components for these. The orange silicone in here I use. And then you take this apart and you've got this little spring. This catches the solder. And then in here on the back side, there's some ceramic filters. And I make these up myself too. I buy these and I have a little die cutter and I'll spend an hour making up enough for a year. And then in the hose here too, in the hose that's the vacuum tube, one brings power up for the heater, and then the other one is the vacuum that comes out. So again, I'm not carrying the old vacuum pump in my hand like the old 808s that I used for many years. So hit the button, and I have different size tips here. A lot of times what I'll do is I'll go in with a tip tinner like this, lead-free tip tinner, and you'll see how nice and shiny it gets at. I probably won't want to focus, but it makes the tip really nice. And then I've got a little pad over there. And then a lot of times what I'll do is I'll take one of these little pin probes and just run it through, make sure that there's no solder in there. So here's we'll do the capacitor, the electrolytic first. So I'll literally just put it on here, pull it to the side, hit it, and then put this on the other side, drop it, and then you can see we've got both of the holes are cleared there for it, right there. And then, oops, it fell behind. There's the old cap, and then we'll take out the glass passivated here. I'm trying to get this where the camera, you can see what I'm doing here. Okay, remove the solder, and then I'll come in with a pair of little diagonal side cutters here, flush cutters they call these, or dikes. There's different terms depending on who you talk to. And then I'll just come in, and there's one end of that broken one, and then here's the other end. So far we've got both capacitors, and we've got the ribbon cable removed, and now I'll pull off these 10-pin headers, and then I've got enough boards, hundreds of these probably. But what you can do is, if you're looking at the board here, if you're going to do this yourself, because these are keyed differently, and you could just make a little chart if you want, but I throw these away or I return them to the customer. So I'll just put like an L here for this one and an R here for this one. Right, there's a little L and R for me, so I'll pull them both off together. Usually what I'll do is I'll just set them up here, in the same orientation, and then with the new ones, I'll cut the keys, before I leave the bench. So let me go ahead and desolder these really quick. Keep in mind, as I mentioned, 2 pins are ground. Here's one, and then here's the other one. And these ones you're gonna have to leave the desoldering on a little longer. You have to be aware of what you're doing. That's the ground plane will wick a lot of heat away from the tip of this. So just kind of set it for a minute, and then I'll do both grounds first, get them out of the way. So there's those desoldered, and then we'll go through and trying to find a decent angle here. Maybe I'll do a zoom in again. I know I need to work on the lighting here. My head looks like it's glowing. And this camera I bought is a 4K camera. It's a webcam, but it's got a Sony lens on it. It was supposed to be pretty good at autofocus, and we'll see. So there's one. We've got these 10 desoldered. So then what I'll do is I'll flip it over and just kind of rock it. Well, it didn't take much. With a good desoldering gun, it's pretty effortless. It looks easy. You have to be aware of how long you're holding it on. The heat, you don't want to lift pads. I've been doing this a long time, probably 40 years. So there's the L. So again, I'll set that kind of there for now, and then we'll come back and do these last. Let me get in a better position here. And I am old and shaky, but this is the problem here is I'm trying to do this where the camera can see it, and it's not my normal comfortable orientation. So here's the other one. Again, just falling away. So there's the 2 Molex headers with the round pins. We've got the ribbon cable. We've got the electrolytic and the glass passivated decoupling ceramic capacitor. So I'll put and the other thing that bugs me on these that I always do, I'll hold it up here. If you look here at these two capacitors, see how they're kind of bent over and angled? Somebody's bumped them, or could have happened in the factory. And even this one up here is not straight. So I've got these little duck-billed flat pliers I use for straightening pins. I've got quite a few. And what I'll do is I'll come in here and just straighten these, give them a little straighten. And then while I have it down too, again, this board was pretty clean, but I have like a paintbrush I use here. It's been pretty old. I just wipe all the dust off, especially with that connector gone. And then the other thing I do when I'm always working on boards, now keep in mind most boards, I'll do a full tear down of all these, change all these parts out before I even put on the bench. Really to me it doesn't even matter what the customer's complaint is. Um, the key for me is when it leaves my shop, it's going to be right. So I'm not super concerned with what the complaint was. If it was something that's very intermittent or something very unique, then yeah, occasionally I'll put them on the bench ahead of time, but very rarely. But then I'll go through. I also have like a magnifier, and I also wear typically one of these little, magnifier jewelers, and I'll go through and look at traces. I'll inspect, make sure none of the tails off these dip ICs and stuff are bent or touching. And just inspect everything real good. And over here on the board, some flux that was from desoldering, that'll come off when I clean up after we put the new components on. So let me go ahead and populate now the decoupling capacitor. Again, I've already sized this correctly. Say it dropped right in there, right here. And then I will bend the leads just ever so slightly on the back. On those. That's about as far as I go, maybe 20 degrees or something like that on those. And then this is the slick one. Again, this is the electrolytic. So there's the plus. You can see the plus sign, which is always closest to the ribbon. And then on here, I've got the longer leg. So I'll put that long leg in the plus hole, and then I kind of get that down. But it's under like spring tension because I bent them. And then what we'll do is when I push it in, I'll rotate it, kind of overcoming that spring pressure, and then push it flush. And now it stays in on its own because those two leads are pinching inside that hole. So I don't have to bend these out at some weird angle. And it is flush with the board. It's down all the way and it's not going to come out. So now what I'll do is I've got a little flux gun here. This is what I'm running right now. This is, I think, a 559. It's a gel flux, and then it's in this little pump syringe. I just, peel this lever down, and it'll force the plunger in and give me a little bit. I have a pretty small tip on here, um, just to put, precisely put the flux where I want it. And then I have a little holder. I actually have a pretty cool little holder I built. I downloaded the STL. I 3D printed it a while back, but this holds the unit in, and then any drips out goes on a little tray here. And the interesting thing, this thing was so light because you 3D printed it that it slid around on the bench. And so what I did is I got some wheel weights off Amazon for another project to weight down a box. But these are adhesive back. They use them for balancing your tires on big trucks. They're just a couple ounce each, these wheel weights. And I put 1, 2, 3, 4, 5, 6, 7, 8 of them on there, and then some little foam anti-slip pads, just single side. So this thing is pretty heavy. So when I set that down, and then I put my flux in there, it doesn't want to move easily, slide around the bench. So anyway, so we have those fluxed up. I'm going to get my solder here. Let me zoom in a little bit maybe for you. Oops. There we go. And then okay, those four are soldered. Turned out really nice. And then I have those flush cutters, and we'll just go in and snip that one and those two. And here's all the little ends. Throw those in the garbage. And now I've got some new 10-pin Molex headers. Here's the new ones. Here's the old ones. And you can see these have the square pins. So again, the pins that are in your harness are flat, and now they're going to be touching the flat edge of these. I recommend putting the Trifurcon, which actually touch on the sides and the front edge, so you get 3 nice wide connections. And the other thing that I use, I'll show you on these, I have these ceramic tweezers. Let me zoom out. So these are spring-loaded ones. So as you squeeze, and then they retract on their own, and they've got pretty good little bite there. I mean, they're not going to fall off of anything. I use these for holding ICs that are close to the edge of board when I'm putting them on, right? I can do that. But what I do is I put these new 10-pin headers on here. Now sometimes if like that one, the hole's pretty snug, and then here's the other one. But they're, it can fall off. It's kind of loose. So what I do is I take these tweezers and I put them right on that edge. So that way too, if you look down the backside there, they're both perfectly aligned on the little ramp, the friction ramp. It looks like one long 20-pin connector. So putting that little bit of pressure there keeps those aligned. So then we'll come in here again with the flux. Brad, doesn't the solder have a flux core? Yes, it does. You get a much nicer joint, much better flow by adding a flux. Plus the flux in the core is, like a rosin based, which is basically pine tar. So, it's a little stickier than this stuff. This gel stays pretty nice. So I clean my tip over here. That's what she said. And then we'll hit these. This is where I kind of wish I had my little exhaust fan going. These larger connections use a little bit more solder and generate a little more smoke from the flux. People, another misconception, people think, oh, you're breathing lead. Well, the soldering iron is, I run pretty hot. I mean, mine's close to 900 degrees, but most people run probably around 700, 750, something like that, which is well below the, the boiling point of lead. So you're just melting it. You're changing it from a solid to a liquid. You're not changing it from a liquid to a gas where you're going to breathe it. The smoke that's coming off is from the flux core. It's basically like an oil. So there's all 20 of them soldered. That's done. I can pop these off. So then what we do now is, again, I've got my little solvent here. Pump that. You can see it coming in. And then I have brushes that I buy. These are actually pretty expensive. These are boar's hair brushes. And most people get those super cheap acid brushes or whatever. These things are really heavy duty. Um, the one end comes originally as a V, where I go through these pretty quick. I think I might have one that's new. Let's see here. Yeah, here's a new one. This is a Tech Spray. Here's the number for those that want to know. Tech Spray 2032. The one side is what they call a chisel tip. It's kind of pointy. And then the other end is this. And this is boar's hair, horsehair. I think it's boar's hair, to be honest. It holds up to all the solvents and chemicals real well, and they last pretty good. I found out that the actual hairs go up pretty far in here. So what I do is I take this end and I'll put it in a vise and squeeze it, and then I'm able to pull out the shorter, if these things get real short, and pull out and then recrimp it in the vise, and I can get a lot more use out of these. But I go through these things like crazy. I think I have one here I'll show you that's pretty wore out, an old one. In any case, they work very well though. I would highly recommend getting one if you do any sort of volume of work. So again, I'll just put this in here. We'll get get that saturated. And I'll get my little t-shirt on standby here. So usually what I'll do is I'll just go over where I did it and wetten it with the alcohol, wipe it a little bit. Not super aggressive, and then I'll get the tip, because then again that's going to have some of the the flux on it. Oops, I got two by mistake. And then I'll just do like an ancillary wipe. A lot of people, Brad, can't you leave the flux on the board? Yes, this is a non-corrosive. It would be absolutely fine to leave it. My thing is that I always clean it. When I'm done repairing a board, I want you to think that it's never been serviced. If you know, by looking at it, you can't tell. So then again, I go over it now, wipe it down, and I'll show you the solder joints here. Let me try zoom. I don't know how well these are going to show up. Pretty good. They look pretty good. I'm happy with them. Keep in mind, I've probably done a million. I don't know. Been doing this a long time. And then there's the electrolytic. You can see. Let me see. I got my little pointer deal here. There's the connection for one side and the other. And then over here is where I put in that glass passivated capacitor, which is here. And then again, there's the niche count electrolytic, and then the two things. So now what we'll do, I take these same side cutters, and what I'd like to do, because I use these to trim those legs we're touching flux, I will go through and I'll get that wipe, and I'll wipe these again just to clean any flux off from where they were touching, because I don't want to get them in my nice fresh Molex connectors. And then I will set these up, and again, I've got these labeled. So this is left, and I just kind of set it over top here of this one, so you can see that it was the second terminal there. And I'll put these flush cutters flush and snip it out. There's the old terminal, and this one I get them really flush too. These are really good. And we'll throw that old one away, and I'll throw the old connector away. Again, this one is for a friend. I'm restoring. It's not something a board he sent me, so I'm just going to get. Most of the times I'll return the parts to the customer. I used to work at a dealership years ago when I was going to school, and that was kind of the you had to return the old parts or at least offer them to the customer. So the dealer, I was pretty young at the time. They had me trained like you better put the parts in the trunk or And then here's the other pin. Again, I set this on top and I can see which one's the key. Always double check, right? Measure twice, cut once, because if you cut the wrong one, you pretty much got to redo it. So um, now we've got the two keys cut from the two 10 pins. We've got the new Molex. We've got the new ceramic. And the other thing that I'll do, I got one up here. Oh, here we go. So I have these rags. You can see this one. I go through these things like crazy too. These are from the gun cleaning world. When you get them, they're pretty saturated here. I've got a couple different ones. So here's one that's Allen. It's a silicone cleaning cloth. Here's another one that's a clean bore silicone gun and reel. So, fishing reel cleaning cloth. So it's protects against rust, polishes metal, wood, treated to absorb dirt, blah, 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 blah. So they're just basically little cotton terry cloth thin towels that are saturated with silicone. And I cut them in half. They're more usable. So what I'll do then is go over the board and wipe, and you'll see, how glossy that is there now. Just even that little section I did. And then when you do the ICs, these plastic or ceramic dip ICs, they literally will look nice and shiny and brand new. And there's no residual. They're not slippery. There's very small amount of silicone impregnated in this thing. It's not like it's slippery. So then I'm just going through here and wiping everything down real nice. And again, a lot of boards are beyond this. They need the full simple green bath, but you can see how shiny these things come out. Like look at this one here compared to that one. Maybe you can't see real well. And we also straightened out all those other bent legs on those other capacitors in the snubber circuit. And again, all these snubbers and all these 4049 buffers, these are to do as much as it can to keep the garbage that potentially is in the the control panel, the real world, if you will. Um, People with static in their shoes and everything else, to keep all that outside and keep it off this PIA and anything to do with the microcontroller or microprocessor in this case. So that's everything wiped down. And you can see though this rag does leave some residual little fuzz busters in there. So again, I'll take my little soft bristle paintbrush here, and I will wipe all those out. And now this board's ready to have the ribbon cable installed, and I make up 20, 30 at a time. Every board I work on, I go through one of those. And then I do have here's the old connector, which will go in the garbage as well, and the old ribbon cable, which I've measured. I keep a few of these in a bag with all my ribbon cable parts, and I'll write Defender and which orientation. The red stripe indicates pin 1, and which way the connector faces originally is down, and then it does this big loopy thing, and um, you know. These ones here just kind of bend like arc like that, and I have Robotron. I have them all labeled with the length, and I make up exact duplicates, and they go the same orientation. I do not reuse this end at all. These get worn out and oxidized. So this whole thing will go into the garbage and will be gone. So I may do a video of using the little press for the ribbon cable, and then the next video will be on the bench testing this. So thanks for watching. This was a bit long with the new format here. I can switch back to this one. Uh, Let me know what you think. Again, I've got quite the glare up here from all these overhead lights I need to work on. Um, and I think maybe having a view kind of over my shoulder may be interesting. Um, I'll probably do like a roaming tour too, just to kind of show you my workbench here at some point as well, kind of the soldering iron, desoldering, and how things are laid out, where I have all the tools. Again, I've been doing this quite a while, and people think, oh, I need all these different tools and things, and over the years you get all that, and then you find that you don't use certain things ever, and you get rid of them, right? They just clutter and fill your bench up with stuff you don't really use, and the stuff you use a lot. Um, Certain things I keep. Let me see here real quick. I'll switch over to this again, just the bench cam. So some certain things that I use a lot. Um, Side cutters, and again, I have different types. Some of them I have, these are readily available. They're Play-Doh. I have all kinds of super expensive ones too and stuff, but these ones work pretty good for wires are really thin in the nose here, but they're not going to cut like those pins like these ones will. So those get a lot of use, both of those. I would say this little 90-degree pry tool, pin deal, gets used a lot. I actually keep two of them on the bench because sometimes I'm trying to pry from both sides. And again, these are Snap-on actually. I got my initials on there. I used to work at a dealer. Again, all my tools had a little engraver on them. But sometimes you get in a situation where you want to pry evenly from both sides to get something up. So you keep one or two of those on the bench. These flat nose duckbill pliers, straightening legs on dip sockets, straightening stuff. These ones are real good. These are, I don't know what brand these are. These ones though, which are basically the same thing, these are Hozan, Hozan. The model number is P34. Maybe, yeah, there you can see it. So these are made in Japan. They're really good, high quality. They're not cheap, I'll tell you that. I don't remember how much I paid for these, but I would say at least 50 bucks, something like that. Um, Use those a lot. And then probably the the tool here on the bench is this WIA chip lifter, they call it. And again, it's the same handle they use on their screwdrivers, but at the end here, they've got this little really smooth transition with a little arc, and it's just a little pry bar, and it really works well to pry out ICs, socketed chips. I have some other ones. I actually have a pretty rare. This is a Williams Bally Midway phone number on it, right? A little promo giveaway, and again, that's the same. It's one of the flathead screwdrivers. It was bent as a pry tool, and then again, the brushes that I use, the curved needle nose, and then these ones I use a lot. These are ones, they're just regular tweezers, but they're ceramic tipped, and the nice thing about the ceramic, first of all, they're non-conductive electrically, but they're great when you're using holding to solder things because the metal ones will wick the heat away, and the ceramic is, not only is it a poor electrical conductor, it's a poor conductor of heat as well. So recommend getting you a pair or two of the, I think the brands on here, Coil Master. These aren't great. And then again with the brushes, I do have a little wood brush for getting in tight spots, a real narrow one. Again, I use it with the mixture of the denatured alcohol and naphtha. And an X-Acto knife. I have a couple. This is a little Fiskars brand one. It's got a little rubbery tip, and I keep a couple hundred of the blades around. So use that a lot. Um, that's pretty much it. I do have another pair of kind of duckbill too that I use. Again, these are I think the same brand as these guys here, but these ones are really heavy duty, and I use these for straightening legs on ICs like EPROMs and things that are where they get a bend from the single wipe sockets. So this thing you can put a lot of leverage in, and you're not going to break them. And then the other tool I'll show in another video probably, but is this guy here. This comes from the I think where they make jewelry, like beaded jewelry. So these are like little pliers, but they have nylon jaws in them. And what these are really good for is you can grab on like an axial lead capacitor or even a resistor or whatever, and you grab it and you pull, and it'll make it straight. Sometimes straightening those axial lead components is tricky, and this is a tip I found years ago, and works pretty well. So. Anyway, with that, don't forget to shut off your irons and your desoldering guns and your fans and all that before you head out. So hope you enjoyed the video. Let me know what you think of the new format. There's the part for that ribbon cable that'll be in hopefully the next video. And thanks for watching. Give me any feedback on this format. Too long, too short. I know I kind of rambled on here quite a bit, but deal with it. Thanks for watching. Bye now.